Hey, welcome back, friends, to lesson 2 of our surface area unit. Now, lesson 1, we did surface area of a rectangular prism. Now, before I get into this lesson on volume, I want to remind you of one thing. Now, many of you in the work that we did on lesson 1, you used the new formula, and that's exactly what you should be doing. I want to continue to emphasize, I want you to use that new formula for rectangular prism whenever I ask for the surface area. Like I said before, I know there's the other way, but I want you to use that new formula. It is really important, especially going into grade 8, because that's the formula that they're going to be looking for. Now, this lesson on volume is very straightforward. If you remember volume from the previous years, we're dealing with the amount of space, all right, that an object takes up. So now we're dealing with the inside of a prism instead of the outside, which is what we would have done on surface area. Now, to put this very simply, when you're dealing with a rectangular prism, there really are only two things that you really need to know. You need to be able to identify the base of the prism and what the height of the prism is. Now, unlike the surface area where there was a very specific formula, you have a few different ways of showing this. Now, the easiest way to think about it when you're calculating the volume is you take the area of the base and multiply it by height. Simple as that, okay? Now, if we take a look down here, I'm just going to circle here. There's, like I said, there's going to be a few different ways for you to write down this formula, and you can pick any one that you want. So in this case, unlike surface area that starts with SA, volume is going to start with V. So in the first formula, volume equals L times W, which is length times width, multiplied by height. If we condense all that together, and remember what we did in our algebra unit, you would take those three letters and put them together. Volume equals L times W times H, exactly as we have right down here. Okay? Now, if I go down a little bit further, you may also find out in some place as well, you have V equals AH, and the A stands for the area of the base multiplied by height. Now, to me, I would tell you, if I had to pick one, this would be the one that I remember, because I can take the same formula and use it for any 3D shape that you can actually do. So again, volume equals area of the base times by height. So V equals A times by H. Now, there's only one example that I'm going to go through with this for you. So you can pause the video and do it now, or you can see how I've solved it. That's completely fine. So now, before I get into this, in terms of sketching this diagram, it is again up to you. If you can picture these dimensions inside your head, that's fine too. So let's go through here. We have a deck of 54 cards, fits into a box with the dimensions of 6 5/10 of a centimeter by 9 centimeters by 1 6/10 of a centimeter. I'm asking for the volume of the box, and in this case, I want it to the nearest cubic centimeter. So again, you have to remember what volume looks like, all right? And we're talking about to the exponent of 3 if you're forgetting. So again, if you can picture that inside your head, and remember the formula, area of the base multiplied by height. So I'm just going to sketch over here what some of you might be thinking inside your head. So if I have a simple rectangle, I'm going to just put 6 5/10, multiply that by 9. Now, my drawings are not to scale, and that's not the issue. The issue is I want to be able to see exactly what am I talking about. So 6 5/10 by 9 centimeters is what the formula, the numbers you're going to be using to calculate the area of that rectangle. We've got that. But you have 1 6/10. The way to think about that is think of that as the height of your diagram. Now, again, I flipped this shape on its side. So if I was actually sketching it, and I sometimes like to do this, I may give it like a 3D kind of effect. And I may put the 1 6/10 over on the side here to show that we're talking about that. Now, if I can picture this prism flipped up, now I might have an easier way of seeing that 1 6/10 actually does stand for the height of that one. But no matter which way you have it, the first two numbers are the ones you're going to focus on because those are the numbers that are going to give you the area of the rectangle itself. Now let's go through the example because in our textbooks they draw it way nicer than what I have here. So here's the shape. So again, they have the 9 by 6.5 centimeters. We have that. And then they have the height of 1 6/10. Now the formula they have here, I'm going to circle it. All right, that's still line 1. Volume equals length times width times height. You're going to take all those numbers and simply put them together. Use your calculator, figure it out, and you're going to have an answer of 93 6/10 of a centimeter, which they wanted us to round to the nearest cubic centimeter, so you would round up to 94. And my exponent is 3. All right, so it's as simple as that. So when you're thinking volume, think of the new formula. Volume equals length times width times height. That is line number 1. I want you to remember that equation and ingrain it inside your skull, and then go ahead and figure out all of the work. And again, if you don't need to sketch these out, you don't have to. You just need to be able to identify which one of those numbers will give you the base, which one's the height, multiply it all together, and you've got it. All right? So good luck. Go ahead and do today's work, and then we'll have a next lesson, lesson 3, where we're going to jump back to surface area again, but we're going to do it with other solids. So good luck, and we'll see you next time. Bye.